Finally, we are about to talk about vectors. Vectors are used all the time in MATLAB. If you have some experience from other languages, well, vectors are simply arrays. They are a collection of some data. It can be numeric data, it can be text data, it can be any type of data. Some examples of information that can be represented as a vector, for example, the pixels of an image. Well, it's not really a vector, it's a compilation of vectors, but every row of the image can be a vector, and every pixel has a color that is represented by a number between 0 and 255. Another example may be coordinates in space. You can use them to collect data in real time from some sensor maybe. How often you changed the oil in your car, in the engine, how much protein intake you had this week. Pretty much anything that can be measured can be represented as a vector. We will see many different usages of vectors since we are now going to use them all the time. It's important to get used to working with vectors and thinking in vectors because most MATLAB functions are vectorized, meaning that they can work and are designed to primarily work with vectors. MATLAB is built around vectors and matrices, which are multidimensional vectors. As I said in the beginning, MATLAB stands for Matrix Laboratory. So, let's create a simple vector. Vectors can be assigned to variables, so let's first create a very simple vector called myFirstVector equals. In order to create a vector, we need to use square brackets. We've seen them before, and now you will understand why. Now, let's say that we want this vector to have 5 elements in it, just some 5 random numbers. These numbers must be separated either by a space or by a comma. So, 5 random numbers, just pick some numbers. So 5, 2, 3, 8, 10, let's say. Now, if we run our code, we can see all the values of this vector. If we want to access a specific value of that vector, we need to use indexing. Index is the spot of each element in the vector. For example, the 3 in this vector is the third element in the vector, so its index is 3. The 8 is the fourth element, so its index is 4. So 1, 2, 3, 4. Now, let's say that we want to get the number 3. To do this, use the name of the vector variable. So my first vector, open normal brackets, and supply the index of the number that you want to get. So let's say 3. Let's try with something else. So vector of 1, the 5, my first vector of 5, my first vector of 7, and here we get an error saying that index exceeds matrix dimensions, meaning that we don't have a 7th element, we don't have anything on the 7th index, so you can index only elements that are actually in your vector. Something to note here is that if you have experience from other languages, usually indexing on arrays starts from 0. So in other languages, the 5 will have an index of 0, the 2 will have an index of 1, the 3 will be 2, the 5th element will be 4, and so on. In MATLAB, the indexing starts from 1. So the first element has an index of 1. Now let's say that we want a vector that has 10 numbers in it from 1 to 10 with an increment of 1. We can type this vector and do whatever we want with it. That's easy. So let's do it. So 1 to 10 vector equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That was easy. But what if we want to create a vector that has numbers from 1 to 1000 with an increment of 1? Are we going to manually type 1000 numbers? Of course not. There are 2 ways to generate evenly spaced vectors in MATLAB. The first is to use the so-called colon operator. Instead of square brackets, we're just going to specify the starting point of our vector and the end point separated by a colon. So if we want from 1 to 1000, we will do it like this. 1 colon 1000. Now, I'm suppressing the output here because I don't want to get 1000 elements in my command window. Alright, and you can see here that 1 to 10 vector now is 1 by 1000. To confirm its elements, let's get 1 to 10 vector and let's get the element at index 999. Should be 999. If we get the element at index 1000, it's the 1000 number. If we get the element at the index, let's say 150, we get the number 150. So we have an evenly spaced vector with 1000 numbers from 1 to 1000 with an increment of 1 between each number. And you don't have to start from 1, you can start from a different number. So let's start with from -10 to, let's say, 80. So we will generate numbers between -10 and 80 evenly spaced by 1. As you can see here, we got 1 by 91 vector, which means that we have 91 elements in that vector. If I take the, let's take the 10th number, this is -1. The 11th should be a 0. Alright, but we can also change the step between the numbers. If we want, we can create a vector that increments by 2, not by 1. To do this, we have to supply a third number in the middle between our start and end, and then we have to use an additional colon operator, like so. Now we will generate again a vector between -10 and 80 with an increment of 2 between the numbers. But let's reduce this to 8 so that we can see all of the numbers. Let's unsuppress the output. So we get -10, -8, -6, and so on until we get to 8 with an increment of 2. So we have start, step, end. Now, there is a second way to do this kind of vector generation, and that way is by using the linspace function, short for linearly spaced. The linspace is a function that takes 2 or 3 arguments. The first 2 arguments are the start and end points, so we can create the same thing that we wanted above. Let's again create a vector, so 1 to 1000. So we want again 1 to 1000. Let's see if this is going to work. So we have 1 to 1000. Not really. We don't actually get the same thing. We only got 100 numbers in this new vector. If we check the vector 1 to 1000, the first element in the vector is 1. The final element, the 100th, is 1000. Just as we said, we want the end number to be 1000, but we have only 100 elements in that vector. Let's check another random number. Let's take the 43rd number and we get some strange number, some fraction, 424 point something. This is because the linspace function generates 100 numbers, evenly spaced, linearly spaced between your starting point and between your end point. Even if we change this to from 1 to 10,000, we are still going to get only 100 numbers. Now, the third argument for our linspace is specifying how many numbers we want to get in our final vector. If we want to generate the same vector that we intended to create, from 1 to 1000 with 1000 elements in it, we have to supply again 1000. And now, as you can see, we got 1 by 1000. So if I use the 1000 index, we get a 1000. If I use the 437, I get 437. Now, you may be wondering, why do we need 2 different ways to perform the exact same task? Oh, this is where the third argument for linspace comes into play. The third argument is not the step between the start and end points, it's the number of points that we want to be generated between the start and the end, just like we just saw. If I change this to 10, like this, we get only 10 numbers, we can even see them, we get only 10 numbers between 1 and 1000. 1, 112, 223, 889 and 1000. So it's an evenly linearly spaced vector. You can even give it 1 million numbers. So this will create some fractions. 1 to 1000 of 40. It's 1.0039. All right. So if we say 1 to 10 with an increment of 2, we are not going to get 13579 like with the other way, but we will get only 2 points, which will be 1 and 10. Let's use our close, clear, close all. All right, and suppress this. Alright, so 1 to 1000 is 1 to 10. To recap, the difference between the colon operator and the linspace is that the colon operator gives you control over the incrementation between the start and end, and linspace gives you control over the quantity of points between the start and the end. So this is the two different types of control that you get with these two ways.